Alright, so today we're going to be talking about measures of central tendency. And that's a big fancy phrase. You've learned all of the measures of central tendency already in other classes, because measures of central tendency, they're just averages. So we are just going to write average right there. That's the definition of central tendency. So that's like, what does the center of the data look like? What's the trend or the tendency of the center part of the data? And that's why we call that the average. So these three, you've seen all of these before, so we're just going to go very quickly through mean, median, mode, and range. The mean is the type of average that we get when we add up all the data values and divide. So we're going to say it's found by adding up all the data values and dividing by the number of values. So, and dividing by the number of values. So that's probably the most complicated of all these averages. The median's pretty simple. That's the exact center of a set of data. The exact center of, and I think I'm going to call that an ordered set of data because we need it to be in order from smallest to largest. So the exact center of an ordered set of data. Alright, then we've got the mode. This is the one that we think about the first thing, the earliest when we're learning math. The mode is the data value that occurs the most often. The data value which occurs most often. Alright, and then we've got one more word, and that word is range. So the range is just going to be the range of our data, the distance between the lowest and the highest point of the data. So the distance from the lowest to highest point, the distance from the lowest to highest point of the data. We've gone through all of these before, so we're just quickly going to see how to recalculate them if we're not sure. So in this example, the weights in pounds of 6 members of a basketball team are as follows. It wants us to find the mean, median, mode, and range. I'm going to take these and I'm going to reorder them so that they are from the smallest to the largest. So I'm going to take my 6 data values and say it's 150, 150, 156, 156, 161, and 163. Let me move that over here. So those are my data values. Now that they're ordered, I can do everything I need to with them. So first I've got the mean, and for the mean, I'm just going to add all my data values together. Let's make sure we can see there. So I've got 150 plus 150 plus 156 plus 156 plus 161 plus 163. And once I get my number, I'm going to divide it by the number of data values I have. So I'm going to say 1, 2, 3, 4, 5, 6 data values. I'm going to take 936 and divide it by 6, and we get 156. So over on our paper where it says mean, we're going to write the mean is 156. Now the mean is what a lot of people consider the true average. So the mean is what's most accurate most times. It tells us the best representation of what our data is actually doing. There's some things later on that are going to affect the mean and make the mean a less good average to use. But for a general data set, the mean is what most people talk about when they're referring to the average. The next one's the median. We talked about medians when we did box and whisker plots. So we've got our data set. We're going to start from the outside and we're going to go inward to find the exact middle. So cover up one, cover up the next one, and then we've got 156 and 156. Usually when your median would be in between two data values, you'd have to find the middle number of them. But 156 both times means our median is 156. There we go, 156. And then finally our mode. Our mode is the data value that occurs the most often. So we've got 150, 150, that happens twice. 156 also happens twice. We have two modes. We have 150 and 156. And that's okay. You can have two modes. You can also have no mode. Alright, the next one is the range. This is super easy. This is where we just say it's 150 to 163. So 150 to 163, and that's all we have to do there. Now that we know how to find our mean, median, mode, and range, we're going to come down here and we're going to talk about how outliers affect a data set, because this is going to be kind of important to real life. If we have a data set with an outlier, sometimes that changes the way that we would look at the data and the way that we would describe it using measures of central tendency. So we're going to calculate mean, median, mode, and range with an outlier and without an outlier. So the first thing I'm going to do is I'm going to put these in order. So we've got 16, 18, 21, 21, 23, and 75. And so 75, I bet, is our outlier. First, we'll calculate the mean. I'm going to add everything up here. 16 plus 18 plus 21 plus 21 plus 23 plus 75. Divide by the number of values we have, so 1, 2, 3, 4, 5, 6. And we get the mean of 29. All right, the median, we're going to take a look and find our middle data values. So go in, go in, go in, and 21 and 21, so our median has to be 21. And then our mode is the data value that's repeated the most times. So our data value for the mode is also 21. Our range is 16 to 75. Then we're going to recalculate, but we're going to cross out the outlier. We're going to say, I'm just looking at my first 5 data values, and I'm not looking at the outlier, and we're going to see how that changes things. So if I use my first 5 data values, and I find the mean of those, I've got 16 plus 18 plus 21 plus 21 plus 23. That's 99. But instead of dividing by 6 this time, I'm just going to divide by 5, because that's the number of data values I have. So 19.8 is my new mean. If I look at my median, I'm doing the same process as before. Cover up 1 on the end, cover up 1 on the end, and there's a 21 in the middle. So my median is 21. That's my middle data value. My mode is the data value, again, that occurs the most often. So that's also 21. And my range is going to be 16 to 23. So my range got a lot smaller, just from not including that outlier in there. So let's talk about how each of these changed or didn't change. My mean, that changed a lot. It went from 29 to 19.8. It's almost 10 lower without the outlier. So it's changed a lot. My median did not change. My mode also did not change. And my range, it changed a lot. It was 16 to 75, and now it's 16 to 23. Changed a lot. This tells us something about how we figure out the data about a set with an outlier in it. So if we had to describe the average of a set of data, but that data had outliers, it's going to be easier and better descripting for us to choose the median or the mode, since they tend to not change very much. The mean is the one that's very affected by different outliers. The mean can be changed a lot by outliers. So if we're talking about a set of data that has an outlier, we're going to use the median or the mode to describe the average rather than the mean. And that's what it says on the back of your paper. If you turn it over, a data set with outliers can strongly affect the mean. That's the one that gets affected. Therefore, if there are outliers, use the other two as the average instead. So use the median or the mode. Right? In the next example, we're going to talk about what you might use different measures of central tendency for what purposes would be the most important there. So Rico scored 74, 73, 80, 75, 67, and 54 on 6 history tests. Use the median, mean, and mode of his scores to answer each question. Well, we're going to have to find the mean, median, and mode of his scores. First of all, I'm going to order my data set. So I'm going to start from smallest, 54, go to highest. So I've got 67, 73, 74, 75, and 80. And if I find my mean, that comes from adding up all the data values and dividing. In this case, we would divide by 1, 2, 3, 4, 5, 6. So my mean here, I already calculated earlier, is going to be 70.5. My median is the middle data value. So if I take a look, I've got cover up the first ones, cover up the second ones. Between 73 and 74 is my median, so I'm going to call that 73.5. And then my mode is actually NA or none. I don't have a mode because I don't have a data value that gets repeated. That's okay. You pretty much usually wouldn't have a mode in a data set that you collected from a real life situation. A lot of our problems have modes because it's something we like to talk about in math, but oftentimes all of your data values will be different and you'll have no mode. So the next thing we want to ask is which measure best describes Rico's scores. So to answer this question, I have to ask myself whether there are any outliers. And I see 54, 67, 73. 54 gets really low, but it's not really low enough to be an outlier. I would think I would call that not an outlier. So I'm going to say this data set doesn't have outliers, which means the mean is the best. So usually the best data is going to come from the mean, which is 70.5 in this case. So if you don't have outliers, choose the mean because that's usually the best descriptor. But the next question says, which measure should Rico use to describe his test scores to his parents? Explain. So to describe his test scores to his parents, he's going to pick the biggest average that he's got. And in this case, the median is 73.5. So that's our highest measure of average. So we're going to say the median is going to be his best bet when he explains his test scores to his parents because that's the highest average value or the highest central tendency value that we have in this data set.